All right, guys, we're going over the review sheet today. Going over half of it today, half of it tomorrow. All right, guys. Problems 1 through 5, evaluate each expression for x equals -2 and x equals 3. How'd you lose the front page? All I got's full.
How do you lose just the front page?
I'm pretty sure.
Where's the freaking one?
So if we look at problem number 1, we can start off with -2. So we're trying to find out what is the value of 16 to the -2 plus 5. At this point here, we can grab the calculator and say 16 to the -2 plus 5 is
4,096.
4,096.
We just do the same thing again.
Yes. Now we need to do the same thing for when x is 3. So we're looking at 16 to the 3 plus 5. So 16 to the 3 plus 5 is...
Holy crap.
Wait, can you go back?
Oh, crap. Let's see.
4,294,967,296.
No, that's the answer.
Yes, we can simplify it to 4,294,967,296.
How the freak did we get that free?
So with these problems, we can just always put them in the calculator.
Because we don't have any variables we're solving for, we're evaluating it for the given values.
I guess the same way for number 2.
Number 2, so x is 7 times 2 to the what? -3. 7 times 2 to the -2 minus 3. Now notice on this one the -3 is not in the exponent. We're subtracting it from our 2 to the 7 to the 2 times 2 to the -2. -5/4.
That'd be 12.
Then we'll also do it with 3. 7 times 2 to the 3rd. Any other questions on 1 through 5? Questions on 1 through 5? There's going to be 6 of these on the test. There's going to be 6 of these problems on the part 1. So they're all in part 1. There's 6 of them. 6 of these evaluating the exponential equation. Questions on this here, guys? 6 through 11 aren't on the test.
Oh, okay. Heck yeah.
12 through 19, rewrite each logarithm in exponential form. So what we're talking about is going from log base b of x equals y, if and only if b to the y is equal to x. So for these here, they give us the exponential form. We want to they give us the logarithm form. We want to rewrite it as an exponential. Log base b of x equals y if and only if b to the y is equal to x. So for our first one here, log base 9 of 6,561 is equal to 4. So we want to change it from this logarithmic form to b to the y equals x. Well, what's our b, our base value for this here? 9. What's its power going to be? 9 to the 4th is equal to 6,561. B is 9, x is 4, or x is our 6,561, y is 4. B to the y equals x. So what would 13 be?
1/7 to base is always that. 401. That's easy. So the base of the log is always
Base of our exponent.
right.
Exponential.
The exponent's always what's after the equal sign.
So 15. 15 would be what? 15 to the?
Okay. Pretty simple.
So good with 12 through 15. 16 through 19. Same thing, but natural log of x equals y if and only if e to the y is equal to x. With natural logs, the base is understood to be e. So ln of x equals 7. Well, the base is e to the what? E to the 7 equals x.
Wait a second.
Because the natural log's base is understood to be e. Yeah, same thing. But it's just that the base with natural log is understood to be e, so we don't write it. So what would 17 be?
E to the y equals 6.
Yep. How about 18?
E to the y.
Last one. Eight problems on the test are these. Part 1, 32. 14. We've covered 14 of them so far. We've covered 14 of the problems so far.
I know I've missed half the chapters. I have quizzes.
Questions on going from exponential to logarithmic. So there's 8 of them going from exponential to logarithmic. Well, we're also going to rewrite the equation in a logarithmic form. So we're going to go from logarithmic back to exponential. Yeah. So b to the y equals x if and only if it's b of x equals y. So for 20, we'd have log base what? 3 of 81 is equal to 4.
I did it.
Let's look at 21. 1/5 to the third is equal to 1 over 125. So in logarithmic form, we'd have log base what? 1/5 of 1 over 125 is equal to 125 to the 2/3 is equal to 25. Log base what? 125 of 25 is equal to
This is easy.
e to the y equals x if and only if the natural log of x is equal to y.
Okay, well, that's half of the thing. We do 24, technically.
So we'll do 23 first. E to the 4th equals x. So the natural log of what? X is equal to 4. Okay? E to the y equals 27. The natural log of 27 is equal to y. And lastly, ln of y equals 8 problems. Are going to be these. 8. So 8 are going from logarithmic to exponential. 8 are going from exponential to logarithmic. That's 16 out of the 32. That's half the test.
And there's
2 parts.
And that's just half of part one, or
Yeah.
whole test?
No, that's half of part 1. 32 questions on part 1. 8 are going from logarithmic to exponential. 8 are going from exponential to logarithmic. 6 of them so far are just our exponential evaluating. Another 6 are going to be evaluating the logarithms. So doing these here. Now log base 5 of 1 over 125. There's 2 ways we can evaluate it. One is doing change of base and putting it in the calculator. The other is, well, we can take the graphing calculator. I'll clear the history here. What we can do, math. We're going to hit the math button and go up or down to log base. So math, up or down to log base. Now the one we're wanting to evaluate is log base what? 5 of 1 over 125. To get a fraction alpha y equals enter. Yes, sir. Yes. So log base 5 of 1 over 125 is, now it does say to round to 3 decimal places. There is no third decimal place on this. So it's just -3. Questions on number 26? If you want, it might be nice to write down the steps to get to the log base. If you can remember how to do it, you can put those on your review sheet. But if we look at the next one, log base 9 of 2,187. So we can pull the graphing calculator up and go math up to log base. And it's 9 of 2,187, which is 3.5. Now we do have a decimal, but it doesn't have 3 digits, so we can just leave it as 3.5. Questions on this here? All right, we're ready for 28. Log base 10 of 0.00001. Well, with common logs, the base is understood to be what? 10. So one way we could do this one is actually just hit log of 0.12341. Make it -5. Now say we didn't remember the fact that 10 is the common log. Well, I could say log base 10 of 0.12341, which lo and behold is still -5. Questions on 26, 27, or 28? We ready for 29 through 31? Well, 29, natural log of 27. Well, we know the base is understood to be e. It can't be anything else. So I can just do natural log of 27 is not there. 3.295836866. So it asks for 3 decimal places. So the third decimal place is 5, the fourth one's 8. So we would round up to 3.296. If you're not sure on it, now some of them are, because if we had 3.9999, rounding it up, it'd technically be 4.000. If you're not sure, especially with some of the multiple rounds, give me the whole thing. I'm not going to count off because you didn't round the 3 spots. Give me the whole thing if you're not sure. Questions on 29? Questions on 30? Because 30, with natural logs, I can say the natural log of 2/7. Negative 1.2527, 1.253. Logs and natural logs can equal negative numbers. We just cannot have a negative number inside that log. Might as well, we're right here. Natural log of 4 to the 6th. Natural log of 4 to the 6 is 8.3177 or 8.318. And again, there are 6 of these here. 6 of these evaluating logs on the first part. So 12 evaluating, 16 rewriting from exponential to logarithm, logarithms to exponentials. That's 28 of the 32 problems.
So the first half of the test is pretty much just calculator work.
For the most part. Well, under half is calculator work. Yeah, 12 of the 32. Yeah. And again, y'all will have more than enough time to get the 32 questions on part 1 and done in a day. Now we have the last 4 that are on the first part of the test. 2 of them are the expand the logarithm. Now, expanding the logarithm has 3 main steps. First one is our quotient. Log base b of m divided by n is equal to log base b of m minus log base b of n. Our second step is product. Log base b of m times n is equal to log base b of m plus log base b of n. And the last step is power, simplifying our powers. Because log base b of m to the n is equal to n times log base b of m. And we want to expand this out. Quotient, product, power. Because when we get finished with expanding, what's inside each of the logs should be a single term, single number, single variable, single number, with no exponents. So, Log of 6x cubed y squared. Quotients first. Do we have anything being divided inside that logarithm? No. So that means there is no quotient step we have to do. We can move straight to product. Product says if I have two or more things being multiplied inside the log, we could rewrite it as a sum of logs. So here we'd have log of 6 plus log of x cubed plus log of y squared. Three terms inside, so we rewrite it as the sum of three logs. Now, some, especially if you look this one up, will say that we do need to simplify log of 6 a little further because 6 is the same as 2 times 3. Leave it as log of 6. I'm not asking you to simplify it further than that. Questions on product before we do power? Power property says that we take the exponent and move it to the front. 6 doesn't have an exponent, but x cubed does, so the 3 is going to move to the front. Log of y squared, the 2 is going to move to the front. Log of 6 is the same, plus 3 log of x, plus 2 log y. That's it.
I've never guessed if you had it.
Questions on this here? Okay, let's look at 33. Log of 7x squared over y cubed z squared. Now, one thing if you want to give yourself a reminder, is that anytime we have stuff in the bottom of the logarithm, when we're expanding, its log should be negative. And the sign in front of it should be negative, because that's the properties with quotient. What's on top is going to be positive log. What's on bottom is going to be the negative log. So here, how many logs should have a negative in front of it? 2. The one that's going to be with y and the one that's going to be with z. So it's a good reminder to yourself that when we get finished expanding it, those both should be negative. So, first step is quotient. We do have a quotient. We do have division. So when we do the quotient step, it's going to be log of the top, 7x squared, minus log of the bottom, the denominator, y cubed z squared. Log of the top minus log of the bottom. Questions on this here before we look at product? Understand the quotient step. Product, we have 2. We do have first the log of 7x squared, which just like the last one is going to be log of 7 plus log of x squared minus log of x cubed or y cubed z squared would be log of y cubed plus log of z squared, because just log of x cubed z squared is log of y cubed plus log of z squared. But because it's in the bottom of the fraction, we're minusing it. That second half is really just negative log of y cubed minus log of z squared. The first is going to say log of x squared, positive log of x squared, and positive log of 7. So we finished product. Questions on quotient or product so far? We ready for the last one, powers. So any exponent that's there is going to be brought to the front of it. So we'd have log of 7 plus 2 log of x minus 3 log of y minus 2 log of z.
What's your favorite color?
Blue. Questions on 33? Questions on this so far? We ready for 34? And 35. Even though they're natural logs, they're going to work the exact same way as logs. Natural logs and logs are the same thing. So when we look at 34, the natural log of 7x cubed over 16y squared, we still start with our quotient. For us here, instead of writing log, we're going to write the natural log of 7x cubed minus the natural log of 16y squared. Natural log of the top minus the natural log of the bottom. First one. Now we can move on to product. Natural log of 7x cubed is a product. We'd have the natural log of 7 plus the natural log of x cubed minus. We'll do the same thing with the natural log of 16y squared. Now we do have to apply that negative. All right, guys. Last step's our powers. 7, natural log of 7 is just going to stay it, plus 3 times the natural log of x minus the natural log of 16 minus 2 times the natural log of y. This is as far as I want you to take it, because it is possible to take it one step further, and that's dealing with the 16. 16 is 2 to the 4th. So some, if they want it fully expanded, they would want you to rewrite 16 as 2 to the 4th power. Move the 4 out front, so 4 times the natural log of 2 is the same as the natural log of 16. Then it would be technically fully expanded, but this is as far as I want you to take it. Yeah. 2 natural, or 4 natural log of 2 is this here. Natural log of 16 is also that exact same amount, guys. Guys. Questions on how we expanded 34? Let's look at 35. 35, the natural log of 8x to the 3rd y squared z to the 4th. Is there a division inside the log? No, so we don't have a quotient step. We just move straight to powers. And we can rewrite this as the sum as the natural log of 8 plus the natural log of x to the third plus the natural log of y squared plus the natural log of z to the fourth. Power says we move the exponents to the front. Natural log of 8 plus 3 times the natural log of x plus 2 times the natural log of y plus 4 times the natural log of z. Just like with the natural log of 16, we could do the same thing with the natural log of 8, where I'm not going to ask you to. But we could have rewritten the natural log of 8 as natural log of 2 to the third, which is 3 times the natural log of 2. Questions on this here? Are you ready for the next ones? So 2 are going to be expanding. The last 2 are going to be condensing, putting them back together. Now condensing does have 3 steps. The first is powers. And we're going to take the negative with it. Second step is product. And the last step is to simplify. If we have negative exponents, they need to be simplified. We need to make them back positive. If we have numbers to a power, check and see if they do reduce to a nice number, a non-repeated, non-terminating decimal. We have a nice number, a number that doesn't have a non-repeating, non-terminating decimal. So if we look at 36, 6 log of x plus 5 log of y minus 4 log of 3. First thing we're going to do is move our numbers back up into the exponents. So 6 log of x is going to become log of x to the 6. Plus, we're going to move the 5 back up into the exponent, giving log of y to the 5th. Now our negative 4 log of 3, we're going to take the negative with the 4, giving us plus log of 3 to the negative 4th. Because when we take the powers or put the powers back, we're going to take the negatives with it. Questions on this here? Now we have 3 logs being added together, so we can rewrite them as a single log with what's inside of them being multiplied. Now the order that we have them really doesn't make a difference. I like putting the number first, so 3 to the negative 4th will be first, times our x to the 6th, y to the 5th. And the last step is to simplify. X to the 6th is fine. Y to the 5th is fine. But that 3 being to the negative 4th power, we need that negative 4th power to be positive. Well, the only way to make that power positive is to move it from the top of the fraction to the bottom. Like I said, with expanding, if it's in the bottom of the fraction, we're going to have the minus in front. Because it was minus 4 log of 3, that 3, when we got finished, was going to be in the bottom of the fraction. Questions on how we got to this point here? Is 3 to the 4th simplifiable? Is 3 to the 4th a nice number? Let's see, 3 to the 4th is 1. So we could say that this is the same as log of x to the 6th, y to the 5th over 81. If those numbers simplify, simplify them. if for some reason 3 to a power we got 19.84729 going off, leave it as 3 to that power. There's no reason to change it to that decimal. But since 3 to the 4th gave us 81, 81 is a nice number, we'll replace it. Questions on 36? We feel good with 36. 37. Powers first. So 9/7 times log base 4 of x is going to become log base 4 of x to the 9/7 plus 9 times log base 4 of y is going to become log base 4 of y to the 9th. We move the numbers in front of the log back up to the exponents. Now we have 2 logs being added, so we can rewrite it as a single log with what's inside being multiplied. And that's it. There's nothing we can really do with x to the 9/7. It's just 9/7. Variables, powers, as long as they're not negative, which 9/7 and 9 are not negative, that's it. We're done. Questions on 37? Are we ready for 38 and 39? 141. Questions on 37 before we look at 38? "38, 6 times the natural log of x minus 4 times the natural log of 2. Again, just like before, we can move numbers in front of the logs back to exponents. So 6 times the natural log of x is going to be the natural log of x to the 6th. Plus, we're going to take the negative with the 4, telling us that we have plus the natural log of 2 to the negative 4th. Now, since we have 2 logs being added, we can rewrite it as a single log with what's inside being multiplied. Questions on this here? We good up to this point? Yes, no? Do we have negative exponents? So we have to take that 2 to the negative 4th and get that exponent to be positive by putting it in the bottom of the fraction. Now 2 to the 4th is nice, it is 16. And to figure that out, all we got to do is take the calculator and say 2 to the 4th power, which is indeed 16. We can replace it. If a number is to an exponent, plug it in the calculator, see if it gives us a nice number. If it does, replace it. If it doesn't, leave it as that number to a power. Like say 2 to the, let's say 15/7. That's not a nice number. Leave it as 2 to the 15/7. But most of these should end up being nice numbers. We're ready for 39. So again, first step, power property. Move the numbers in front of the logs back up to exponents. So 2/3 times the natural log of x is going to be the natural log of x to the 2/3. The next one, negative 5/3 natural log of 27, we can move negative 5/3 back up, giving us plus the natural log of 27 to the negative 5/3. Since we have two logs being added, we can rewrite it as a single log with what's inside being multiplied. And again, the 27 is to the negative 5/3. So to make that exponent positive, we've got to move it from the top of the fraction to the bottom. (27 to the 5/3). Let's see if this gives us a nice number. 243 is a nice number, so we can replace it with 243. So we have the natural log of x to the 2/3 over, what was that, 243. Questions on this here? All right. So that is everything that's going to be on part 1. Everything that's going to be on chapter 6, part 1 test.